Okay, solid doses. And then we went over that last week. So let's look at chapter 9. So I don't want 8. Okay, now what is this pen doing? Okay, chapter 9. Okay, so we have some keywords on page 164 at the beginning of the chapter. We used to have this thing called an expiration date. And the expiration date is the legally, if you take a tablet after that date, the drug company is not responsible if, you know, something happens to you, basically, because, you know, there's an expiration date. Now, some pharmacies would put an expiration date of 1 year from the time you filled it, as long as the expiration date on the bottle was after that. So they would cut it down to 1 year. I would always set my computer to leave the expiration date blank so I could write the expiration date that was on the stock bottle so that patients would know exactly, you know, when that expiration date was. However, now, depending on how the medication is, you know, how it's stored, manufacturers won't go all the way to their expiration date if you have repackaged it sometimes. So now they're calling it a beyond use date. Now the beyond use date usually could be a shorter date because you have repackaged this medication somehow. So for instance, if you have a powdered drug that that comes in a powder form and it has to be reconstituted, the expiration date on the bottle could be a year or 2 from now, but then once you reconstitute it with something like sterile water for injection, then it's only going to be good for a certain length of time. Now, sometimes it depends on where you reconstitute it, whether you do it in sterile conditions or not. But if we're talking about an oral, something like ampicillin that's used for little kids with ear infections or other infections, then it's usually going to be 14 days on that medication. So now they're calling it a beyond use date. It's the date assigned by the pharmacy to a reconstituted or repackaged medication beyond which the preparation is no longer considered usable. Then we have diluent, and I've heard this called diluent also. A diluent is an agent that dilutes a substance. In pharmacy, the liquid added to a powder to change the powder to a liquid, or the liquid used to dilute another liquid, also known as the solvent. So the solvent is what you use to dilute it with. The solute, which is in the next column over, is the dosage form in which the medication is completely dissolved in a liquid before you can use it. The substance that's being dissolved. In this chapter, it's going to be the powdered medication. So going back over to the left side of page 164, and we looked at diluent, let's look at Elixir. Elixir is a sweetened flavored medication that's dissolved in a mixture of alcohol and water. And then we already talked about expiration date. The graduates, honey, could you bring me a graduated cylinder from the kitchen, please? Yeah. It's a container calibrated in the metric system, so it's in milliliters, that are used to measure liquid. And then another way of getting these powders into powder form is we can freeze dry them. When they're freeze dried, that's called lyophilized. So a lyophilized medication is freeze dried. A lot of times, instead of being a powder like this that you know, can flow around, a lot of times a freeze-dried powder forms a solid cake. Yeah, can I get some water in a, no, in a, like the Pyrex measuring thing? Just fill it up with tap water for me?
Yeah.
Okay. Okay, so, so it becomes a solid cake and it just sort of sits in the bottom of the container. Perfect.
You want it colored?
No, this is fine.
Okay.
What would you color it with?
Grape juice. You can see it.
Okay, yeah, that would work. My husband is home today and he's helping me, so, which is very nice to have him home. Okay, meniscus. The meniscus is the curved line that develops on the upper surface of a liquid when it's poured into a container, and we always read at the bottom of the curve at eye level. So in this case, if we have a liquid like this, and let's say that's 5 mLs, and this is 4 mLs, the liquid is actually at about the 4.5 mark, right?
Might work.
Thank you.
Please.
All right, cool. Okay, so this curved line here is called the meniscus. And the reason for that is surface tension keeps it sticking to the sides of the container. And so it doesn't get flat, it gets pulled down in the middle and it sticks to the sides, so it makes a curved surface. So that's called the meniscus. And we always read the meniscus at eye level at the bottom of it, okay? The powder volume is the space that the powder takes up relative to the total volume of the medication after reconstitution. It's also known as the displacement value, and it's a measurement of the amount of active substance that displaces or takes the place of some of the liquid diluent. In other words, if we have a bottle containing amoxicillin, and the whole thing, once you reconstitute it, is 150 milliliters, but then it tells you to reconstitute with 104 milliliters of water. Why am I not putting 150 milliliters in that bottle?
Because we need to add the powder, the active ingredients.
Exactly. So there's already some powder in the bottom here, and that powder is taking up space. Now the powder has a weight, but remember, some powders are going to be like very light, like talcum powder, and not weigh a lot. And other powders are going to be really heavy, okay, and take up a lot of space. So, so what we're going to do is we're going to take the 150, subtract the 104, and we have 46 milliliters that we didn't have to put in here because that's the space this powder is taking up, right? So that's called the powder volume. Okay, so the powder volume is 46 milliliters. All right, does that make sense?
Yes.
Okay, good. Now, reconstitution is the process of adding fluids such as distilled water to a powder or crystalline form of medication to make a specific liquid dosage strength. Because if I add more water, it's going to be a lot weaker, isn't it?
Yes.
Yes, so in order to make it whatever the drug company says it is, let's say it's 250 milligrams in 5 mLs, and we add the 104 milliliters of water, we're going to end up with 150. If we were to add more water than that, then 5 mLs is going to contain less than that because it'll be weaker. Okay. So the solution is once it's made, it's called a solution because solutes are dissolved in it. And the solute is usually the drug in this case. The suspension is a dosage form in which small particles of liquid are dispersed throughout the liquid, or small particles of medication, and most require shaking before dispensing and before administering. So with the suspension, they always need a shake well sticker. Okay, so that's your auxiliary label. It has to say shake well. Now, some of these need to be refrigerated and some don't. So you might also need a refrigerate sticker. And then a syrup is an aqueous, which means water-based solution sweetened with sugar or a sugar substitute to disguise the taste. So syrups are usually a little bit thicker than elixirs. Now, elixirs legally contain alcohol, right? So in my other class in pharmacy law, we're learning about a disaster that took place in the 1930s involving a sulfanilamide elixir. And it was dissolved in diethylene glycol, which is antifreeze, and it killed 104 people. We're sure of 104, there may have been more. And the reason that the US government was able to prosecute and fine the company, the Massengill Drug Company, is not because it was poisonous, because there really weren't any laws against that, believe it or not. But the reason they were able to prosecute them was because they called it sulfanilamide elixir when in fact it did not contain any alcohol. Okay, so that was kind of interesting. It's like how they got Al Capone on tax evasion instead of getting him for transporting liquor across state lines. So, you know, there's loopholes in these kinds of things. So anyway, looking at Chapter 9, now it is illegal, of course, and to put something toxic in medication. So now we wouldn't have to get them on whether or not it's an elixir. Okay, so looking at page 167, oral liquid medications include solutions, tinctures, elixirs, suspensions, and syrups. Okay, so let's say that we have a liquid medication, and when we add, and it's got particles of drug in it, and if these things are completely distributed evenly throughout the liquid, it's called a homogeneous solution. Okay, but if they're not distributed evenly and they remain separate from the liquid, what's going to happen over time is that they're going to settle on the bottom, and you'll have a lot more drug on the bottom than you have at the top, right? And this is called heterogeneous. Okay. And I'm probably spelling those incorrectly. I think I have an E here and I don't have an E over here. So right there, I mean, there might be an E there. But anyway, heterogeneous or heterogeneous. And these are the ones that really require shaking because all the liquid goes to the bottom. So something else I'm going to throw out there that's a side note, because you know how I love to go off on these tangents that don't mean anything, but they're important. Let's look at the way that suppositories are made. Suppositories are a mixture of something fatty or waxy that, that melts at room temperature. Sometimes they use something like cocoa butter or vegetable, solid vegetable oil. And they mix it up in a beaker over a flame, and it melts all together. And then they pour it into the suppository mold. So then as it solidifies, the drug particles will sometimes go to the bottom. So if you have a baby that you want to use a half a suppository for like an infant, and you need to use a half a suppository, would you cut the suppository in half that way?
I
No.
think no.
Lengthwise.
Yes, you always want to cut suppositories lengthwise. Okay, so you always want to cut suppositories in half lengthwise. Okay, so that's a little side note here, but since we already went over solid dosage forms, I want to make sure that we talked about that. Okay, so an elixir has more alcohol, a syrup has more sugar. What about a tincture? What is a tincture? And I'm looking through my book here. See if I can find the actual, and I don't see it. Okay. I bet it's in the pharmacy textbook. Let me see if I can find tincture. Tinctures are oftentimes, or most of the time, they're topical, but they're still a mixture of stuff. Huh. I'm not finding it in the index. Let me see if I can find it in the glossary. Nope, it goes from tinnitus to tort. Okay. So a tincture of opium is similar to an elixir, but a tincture that's topical is something like rubbing alcohol on a sore muscle. Okay, so that's the tincture. Oral medications given in liquid form are absorbed more quickly than solids that have to dissolve before they're absorbed. Most oral medications are absorbed in the small intestine, although some are absorbed beginning in the mouth or stomach. Okay, so we have little capillaries under our tongue, which is why we can do sublingual medications, right? Okay,
Yeah.
So some things start to absorb in the mouth and in the stomach, but most absorption takes place in the small intestine unless they're enteric-coated formulations that dissolve in the small intestine, right? Or, yeah. Yeah, so even the ones that dissolve in the stomach are mostly absorbed in the small intestine. Does that make sense?
Yeah.
Okay, good. Okay, so on page 167, we have an oral syringe, which looks something like this, right? So I showed you guys the oral syringes with the markings. And this one has a little piece of tape around it to show where to draw the medication up to. Apparently, I was supposed to do 0.7 milliliters of whatever drug this was for my dog. So they actually put a little tape with a red line around it to show me where, like I don't know where 0.7 is, but that's okay, because a lot of doggy parents don't know how to use these things. And it says on here, oral use only, so that you know not to try and inject things with it. Now, could I put a needle on here and give an injection with this?
I don't think so.
Why not?
Shouldn't there be like a special adaptation to the tip for the needle?
Yes, exactly. Yes, so first of all, it's not sterile, so I wouldn't want to use it for an injection. Secondly, it has an oral tip on it, so it doesn't have a lure lock, and it's too big for the slip tip syringe to work. So the needle won't fit on an oral syringe. So that's two things. Oral syringes are not sterile, and a needle will not fit on them, so you don't accidentally use it for an injection. But the markings are the same. So look at figure 9.1, a typical oral syringe, and then figure 9.2, a typical medication cup, a small cup that you can use to measure 1 or 2 tablespoons. And those are very common with things like Mylanta and what's the other one? Pepto-Bismol, right? And then if you look further down, we have medication droppers, and those have a squeeze bulb on the end. Okay, so here's a dropper. So you put it in the liquid while you squeeze the top, and then as you unsqueeze it, it'll pull liquid up inside of it. This is a 1 ml syringe, and it has markings every 0.1. So this one's actually been used quite a bit. It's kind of, I think it got super clean last time I used it. And I was using that for, I was compounding Pepsid for my dog, the one we had a few years ago that had severe reflux. And then we had to give her arthritis medication, and it made it even worse. She would wake up in the middle of the night choking on heartburn, poor baby. Okay, so, and then the bottom picture on that page shows a dispensing spoon. They call this one a dose spoon, because what you can do with that is you can fill it to the line that you want. And for little kids, they like to, if they're old enough to like feed themselves, they can actually tip it and drink it themselves, which they tend to like, because then they don't have to, you know, they don't have to have you squirt something in their mouth that they might not want. It's sort of like they have control, so they like that better. So I think we used that with all oral medications once my kids were able to feed themselves. Okay, on page 168, it shows a pacifier oral medication thing that gives oral medication through the pacifier. The only problem with that is that they have to take the whole dose, and a lot of times they wouldn't get it all out of there. Some of it would remain in the well in the back of it. Okay, and figure 9.6 shows the meniscus, how it's actually 15 milliliters, but on the sides it curves up even more. So just like this one. And the meniscus, it seems to be worse with plastic than with glass. And I think it's because the glass has very smooth sides, so it doesn't tend to stick to it quite as much as it does with the plastic. So you might find differently, you know, depending what your experience is with measuring things. Also, a wide, very wide graduated cylinder will not have as much curvature as a real narrow, skinny graduated cylinder. Okay, so now we're looking at calculating the dosage for these. Get this out of the way here. So page 169 shows how to do it using ratio and proportion. And then the midway down the page, it shows how to use dimensional analysis. I do not care which method you use, but you guys, I want you to show me your work on your homework. Don't just type the answer, because you know, I've sent you the key. So why would you just type the answer? I already know the answers. I want to know how you got the answer. So I would really like it if you guys would show me some of your work, even if it's just like, oh, 125 divided by 5 is, you know, or 200 divided by 25 is 8. Then I know that you did the 125 divided by 5 first, and you got 25, and then you did 200 divided by 25 and you got 8. So it's the correct answer. I would just like to see how you got it, okay? All right, just 1 second. I like to kind of see who's here every once in a while, because I have some people who get knocked off quite often. Okay, so let's look at practice problems A. And number 1 on page 170. It says the medication order is for phenobarbital elixir 60 milligrams, PO, so it's an oral medication, QID. And our stroke strength is 20 milligrams per 5 mLs. Okay, now some of you are looking at that and you already know the answer, which is great. So that's good. Okay, so what volume of medication is needed per dose? So if you're going to do this with ratio and proportion, you would do 20 milligrams over 5 mLs is equal to 60 milligrams over X mLs. There's an X there, and then you would cross multiply, and you would have 20X equals 300. which is 60 times 5. And now you've got x, which you have to solve for x because it's algebra. So you're going to divide both sides by whatever's next to x, which is 20. And you have x equals 15 milliliters. Okay, or you can do dimensional analysis. I want to know how many milliliters. So I know I have 20 milligrams in 5 milliliters. So I'm going to put the 5 mLs on top. 5 mLs contains 20 milligrams. And multiply it by what I want, which is 60 milligrams. I'm just going to put that over 1. The milligrams cancel. 5 times 60 is 300. 20 times 1 is 20. And that's going to equal 15 milliliters because the milligrams are gone. So it has to be milliliters. Okay, is that making sense?
Yes.
Okay.
Yes.
Good. All right. So to me, this particular one looks a little bit smoother and not as confusing as this one. So that's just my opinion, but also we're going to be doing more of this dimensional analysis later. So I would like you guys to get comfortable with it. And then if you continue on with math in general, you're going to see mostly dimensional analysis the farther you go with math. So it's a good idea to know, how to use it. Okay, so let's look at number 6 on page 171. And it says prescribed fluoxetine oral solution 10 milligrams. And what we're doing here is, even though like on page 170, number 1, it says 4 times a day, we're not calculating how much they're going to need in a day or how much they're going to need in a month. We're calculating 1 dose, okay, 1 dose, because it says the question is what volume of medication is needed per dose. So looking at page 171, number 6, the fluoxetine comes as 20 milligrams per 5 mLs, and we want to give the patient 10 milligrams. So we want 10 milligrams, and we have 20 milligrams per 5 mLs. So in order to figure this out, we want half of 20 milligrams, so we're going to need half of 5 mLs, which would be 2.5, right? But if you don't see that right off the bat, and you really need to calculate it, then you're going to start with mLs, because that's what you're looking for is milliliters. So we're going to put the 5 mLs on top. 5 mLs contains 20 milligrams. And we want to give the patient 10 milligrams. So the milligrams are going to cancel, and we have 50 over 20, which comes out to 2.5 milliliters. Now, there's another question here. What is the equivalent volume in the household measurement system? What would 2.5 mLs be related to teaspoons?
Half teaspoon.
Yeah, it's half a teaspoon, because 5 mLs is 1 teaspoon. So if we wanted to do it this way, 1 teaspoon, 5 mLs, and we have 2.5 mLs. 2.5 divided by 5 is equal to 0.5, or 1/2 teaspoonful. And then what types of medication administration devices could be used to administer this dose? So looking back at these, things, you could use just about any of them, couldn't you? Except maybe the cup. The medication cup might be too big, but you could use the dropper, you could use the oral syringe, and you could use the medication spoon, right? Any of those would work. Should you use the spoon out of your dish silverware drawer?
No.
No,
Why not?
because it's not accurate like the dose spoon.
Yeah, it's hard to
Exactly,
find the
exactly.
teaspoon.
It's not going to be accurate. Okay. And they vary, don't they? Like you think it's a standard size, but if you get silverware that's been produced, you know, all over the world, they're showing a lot of difference, anywhere from 3.5 mLs to 6 mLs. And you think it's going to be 5, but it might not be. Okay, let's look on page 173, number 12. It says prescribed acetaminophen 19 milligrams every 4 hours as needed for fever and aching. So we want 19 milligrams. And we have the acetaminophen liquid solution, which is 160 milligrams in 5 mLs. So we're going to need a lot less than 5 mLs, aren't we? We're going to need less than 1/10 of that. Well, a little more than 1/10 of that. So then it says what volume of medication is needed per dose, round to the nearest 1/10. Okay, so 5 mLs gives us 160 milligrams, and we want 19 milligrams. Milligrams cancel. 5 times 19. I keep dropping things today. I've been doing that all week. 5 times 19 is 95 divided by 160. Could you hand me the mouse, please? And I get 0.59375. Now it wants me to round to the nearest 10th.
Calculator's on the very bottom. No.
What would be the 5?
The floor, way back there.
Oh, geez.
I think 0.6.
Yes. So it's going to be 0.6 because we're rounding to the first digit here, to 1 digit, which is the 10th place, right? But the number after it is a 9. So if the number after it is 5 or larger, we're going to round up. So we're going to call it 0.6 milliliters. And then it wants you to mark that on that little dosage dropper there, 0.6. So if you look at it, it actually says 0.3, 0.6, and 0.8 on there. So you would mark it to which line?
0.6. The second line, yeah.
Yeah, so it's the line in the middle. Good. Okay, now look over at the page 172, number 9. We run across this sometimes in the hospital. We've got different concentrations of medication, okay? So we want to give the patient 250 milligrams of cefaclor 3 times a day with food. So we want 250 milligrams. And we have 3 bottles up on the shelf. We have 125 milligrams per 5 mLs. We have 250 milligrams per 5 mLs. And we have 375 milligrams per 5 mLs. Okay, so we could use any of these and we could give the patient 250 milligrams, right? Okay, so what volume would we use for the 125 per 5?
10 milliliter.
Yeah. So now if we're using the 250 milligrams per 5 mLs, wouldn't we just give 5 mLs?
Yes.
Yes.
Okay, so I don't have to do math with that one.
Yeah.
And then what about the 375?
It's almost be 3 and something, I think, because it's more than 2.5, 3, maybe 3.4.
You were really good at estimating, and that's something that I have a super hard time teaching. We know that if we used half a teaspoon, it wouldn't be quite enough, right? Because,
Yeah.
let's see, 375 divided by 5.
Because 250 is double, it's 10.
Yes.
250, it's 5. So it's between them, between both of them.
Okay. So 5 times 250 is 1250 divided by 375.
3, maybe 3.4, 3.5, like this.
And the 3's just keep repeating. So 3.3
Oh,
and a third
3.6.
milliliters. Okay, so that's the answer to all of those doses. What it doesn't ask you is which one do you think would be best? And remember, best is kind of a judgment call. Okay, so just like on your quizzes, when I tell you give me the best or most correct answer, you know, if I were to put 3.3, I'm not going to put 3.33, even though it's more correct, because I tend to think that something like that is kind of splitting hairs, and I'm not going to make you guys do that. So looking at these, okay, if we were to use the 250 per 5, it would be a teaspoon. If we were to use the 125 per 5, we'd need 2 teaspoons, right? So just give you an idea of the picture in your head. If we were to use the 375, we could measure 3.33 milliliters. Let's say that this is a 9-month-old baby, and you're going to have to use a dropper and squirt it in their mouth. Wouldn't you want the smallest possible volume?
Yes.
Yes. Okay, so in a hospital setting, we would use the smallest possible volume so that the nurses could squirt it in there without having to spit most of it out. However, if you're at home and you're sending it home to a mom to give to their child, it's actually easier to measure 5 mLs than 3.33, right?
Right.
So in that case, if they're going to take it home with them, I would probably use the 250 per 5 and just have them give the patient a teaspoon, but measured in a measuring dispenser, right?
Right.
Okay. So, you know, I would probably give them an oral syringe, and that's my take on it, because I think it makes the most sense. And the part of my brain that's like, you know, wanting to be absolutely correct is sometimes at war with the part of my brain that says, yeah, but that's not possible. So you have to have common sense. And it's easier for a mom who's not involved in healthcare field at all to measure 5 mLs than to have her try to measure 3.33. This is where we get these calls from the pharmacy. It's right between this line and that line. Is it okay? And you're just like, I don't know. I don't see it. So look at the bottom of page 173 for the tech alert. It says if the answer to a dose calculation does not agree with an anticipated answer based on the amount of medication prescribed and the dose of medication on hand, always recalculate and ask for assistance if necessary. A dose that seems too large or too small should always be questioned. We have a liquid hydralazine. Hydralazine is either, no, it's not Atarax, that's hydroxyzine. This was hydralazine for an infant who was a premature baby. And the way that they calculated the dose was 7.5 milliliters. So it comes in a 10 milliliter syringe. So in the NICU, I don't often hand out medication in 10 milliliter syringes because they're a little bit bigger. You know, that's the 2 teaspoon version. And I don't have one on hand to show you, but you know how big it is. So I was going to hand it to the nurse, and I said, wait a minute, this seems like a lot. And she said, yeah, that baby, and she's looking at it, and she goes, 7.5 milliliters. Their urine output is only about 20 milliliters in a day, which was kind of like, it's amazing that a baby is so tiny that they're only urinating 4 teaspoons a day. That was amazing to me. And so I said, do you want me to talk to the pharmacist? And she said, yes. So I took it back over to the pharmacy, which luckily is right on the unit. And I showed it to my pharmacist and I said, this baby is like under 3 kilograms. Does this seem right to you? No, in fact, the baby was barely 2 pounds, so it was under 1 kilogram. And my pharmacist looks at it and she pulls it up on the computer and she said, let me fix it. So what she did was she prescribed the injectable version to be given orally, which we do a lot in the NICU, especially something like caffeine, which comes 20 milligrams per milliliter. And you know, it doesn't taste good at all, but usually they squirt it in the baby's mouth and immediately follow it with something that tastes better than that so that they don't, you know, notice too much, hopefully. So anytime you see something that doesn't look right based on your experience, it's always a good idea to question it. And I didn't go into, well, which pharmacist decided that 7.5 milliliters would be good for this baby? You know, I don't care about that. I just care about, here's a problem, let's fix it. And so then I found out later that it was calculated by somebody who doesn't usually work in the NICU. So if that were a 50-pound child on a child's unit, not the NICU, then 7.5 milliliters would be fine, you know, but not for a tiny infant. So that was one case where my annoying habit of questioning things was a good thing, right? Okay, let's look on page 176 and let's look at the label for the erythromycin. When you get these oral suspensions that you have to reconstitute, you have to read the label because right here, if you don't do it correctly, you're not going to have 200 milligrams of erythromycin in 5 milliliters because you're not going to have 200 milliliters total when it's mixed. So anytime you see 200 milliliters when mixed, don't add 200 milliliters to the bottle. So here it says to add 140 milliliters of water and shake vigorously to make 200 milliliters of suspension. So what's that powder volume right there?
60.
Yes, so we're going to end up with 200 milliliters, but we only added 140 milliliters of water. One of these days, the stylist and I are going to be friends. It hasn't happened yet. So 60 milliliters is my powder volume. Now, does it weigh 60 grams? Probably not. I don't know how much it weighs because all the weights are different based on density. Okay, so let's look at my little graduated cylinder. And 140, I don't know how well you can see this. Hold on one second. I got it. A dark piece of cloth.
Oh, hold on.
Yeah. So one of these days I'm going to have all of this stuff filmed all neat and tidy, and then we'll never go back to online classes again. And then I won't need it. Yeah, right. Okay, so I think you can see that a little bit better now. So I'm looking for 140 milliliters. Close that blind right there, please. So I have 130 and 150 marked on here, right?
Yes.
So I want the biggest line between 130 and 150, which is going to be right about there. Yes?
Yes.
Okay. So I'm going to pour the water in here. Okay, so when you get really close to it, you have to wait for the bubbling to settle. And then if I were to keep pouring, I would probably end up with too much. And then I would have to try and pour it back and forth the other way. So what I like to do when I get real close is take an oral syringe and put it in sort of drop by drop. And sometimes I have to do it a few times. Is there a larger one in the kitchen? Okay, till I get all the way up to the 130. So, okay, this is fine. So does that look like 140? Can you see where the liquid is?
Yes.
Yes.
Okay. So then I could pour that into the container of erythromycin and mix it, and it would have the correct concentration of 200 milligrams in 5 mLs. That's why it's super crucial to measure it correctly. Okay, otherwise you don't have the correct concentration there. Now, how does it say to store it on page 176 on that erythromycin label?
Where to store it?
Refrigerated.
Yeah.
What does it say?
Refrigerated.
Yes. So it's going to be store in refrigerator. And how long is it good for?
10 days.
10 days. Yeah.
So this is October 1st. What expiration date would I put on there?
October 10th.
11.
Well, I'm just mixing it today. So
yeah,
my best use date is going to be October 11th.
Okay.
Okay, because we're adding 10 days
10
today.
days.
So 1
Okay.
plus 10 is 11. So that's my best use, and refrigerate and discard after 10 days. And then there's the date on that one. Okay. And interestingly enough, the one that we use in the hospital does not need to be refrigerated. But I think they did a long time ago have to be refrigerated. Okay, down at the bottom of page 176, we have a label of penicillin V potassium for oral solution. So it's PenVK is one of the brand names. And this does not come in injectable form. The injection form is called penicillin G or PenG. And it says to use 60 milliliters to reconstitute that one, or 61 milliliters of water in 2 portions. So when it says 2 portions, it just means don't pour it all in at once because it'll overwhelm the bottle. The bottle has to be able to, the powder has to be able to soak up some of that liquid. If you just pour all the liquid in first and it's not absorbed down into the powder, then it'll just spew out the top. So, you know, that's not good. So you don't have to measure what the 2 portions are. You're just going to pour it so that you still have room to shake. Then you put the lid back on and you shake it, and then to put the lid off again and add the rest of the water, and then put the lid on again and shake it again, okay? So we do a lot of oral suspensions in Children's Hospital because we have a lot of kids that can't take tablets. Let's look at page 178, number 2. This is a drug called amoxicillin with clavulanate potassium. Do you know what the brand name is?
Amoxicillin.
That's the generic name. It's amoxicillin, which would be Amoxil. The brand name of amoxicillin is Amoxil, but this one has clavulanate potassium or clavulanate added to it. So in other words, it's been augmented.
Okay.
So when it's augmented, what they did is they gave it a brand name of Augmentin.
Augmentin, okay.
So that's the brand name, so a little registered trademark there. And so it gives you 2 strengths. This bottle has 125 milligrams of amoxicillin, and 31.25 milligrams of that clavulanate potassium. Okay, so I always thought that we would go by the Augmentin or the amoxicillin because that is the drug. What this is a chemical that causes the bacteria to be more susceptible to the amoxicillin. Because a lot of these bacteria, and we use this a lot in little kids' ear infections. In fact, for a long time, in order to get Medicare or Medi-Cal to pay for Augmentin, we had to have a diagnosis of a child under 8 with a otitis media, which is a middle ear infection, in order to get them to pay for it. So we had to get that diagnosis from the doctor's office before we could bill Medi-Cal for that. Now it's available in generic and it's a lot less expensive and they cover it. But at the time, you know, we had to jump through some hoops to get this for the kids. So the clavulanic makes the cell wall of the bacteria more susceptible to amoxicillin. Because what's happened over years and years and generations is that the bacteria that causes middle ear infections has become resistant, and a lot of bacteria that cause all kinds of infections have become resistant to the antibiotics that we use now. So we're having to use stronger and stronger antibiotics. There was a study done probably about 40 years ago in Holland, I believe it was Holland, where they took little kids with middle ear infections. And of course the moms always want, you know, the pink stuff. And so they would go in with the baby, you know, or the toddler to the doctor with these kids with ear infections. And the doctors in Holland did a thing where they would give them, like they actually did a study where they had choices like, okay, I'll give you the amoxicillin, or okay, I'll give you a different, more stronger drug. Or the third thing was, we will give you eardrops for pain, and you're going to wait 4 days or anywhere from 3 to 5 days, I believe it was, before you fill the prescription. If the baby is still pulling on their ear and crying, then you fill the prescription. And the reason for that was they were trying to see if the baby's immune system, A, would either overcome the bacteria on its own, or B, the bacteria would just go away after a certain period of time. And then they were comparing amoxicillin to this other drug, and I think it might have been an erythromycin type drug, like on page 176. That causes some upset stomach sometimes, so moms didn't like to use erythromycin. And the outcome of this study was that there was basically no difference in how the kids were treated. Within about 5 days, all of them started feeling better. and getting over that ear infection, whether they used amoxicillin, whether they used Augmentin, or whether they did nothing except treat the pain. So that was a very interesting thing. So it took years and years and years for this to catch on in the US. And now finally we're seeing eardrops given for painful ear infections. And then if it doesn't clear up within 3 days, then they give medications. But the interesting thing that happened in Holland was, as time went by, within 3 years, the bacteria grew resistant to the erythromycin, but now became susceptible to the original amoxicillin again. So it just proves that these things, this mutation and this ability to adapt is coming about on a real small level over small periods of time. So bacteria mutate at a much higher rate of speed than, say, dinosaurs, right? Turning into birds. So to me, that was just fascinating. I'm such a nerd. Okay, so we've got this Augmentin, and in the hospital, they go by the clavulanate amount because this can really upset baby's stomach. So they dose based on that, but we're not going to look at that. We're looking at the 125 milligrams of amoxicillin in this. And so the two drugs in that medication we just did, what is the total volume of medication after reconstitution?
75 ml.
Yeah, 75 milliliters. And what volume of diluent should be added?
They put it like 67 ml in the direction, right?
Yes, 67 milliliters of water is added. So if you subtract that, what do you get? Yeah, 8 milliliters, good. So that 8 milliliters is what?
I think this is the powder.
Yes, that's the powder volume. Okay, so that we skipped a question, and we'll put what is the powder volume? 8 milliliters. Now the question above that on the graduate, show the volume of diluent to be added. So on that graduated cylinder next to the label, can you see where the 67 ml line should be?
Yes, but the up down the middle between 60 and 70 and 2 lines.
Yes, exactly. So there's a slightly wider line between 60 and 70, and you're going to go up 2 small marks above that. Okay, so then the powder volume is 7 or 8 mLs. And on the label, what is the first direction necessary for reconstitution?
Like top bottle until powders flows freely. Then,
Exactly.
yeah.
Because sometimes these powders will clump together. And if you try to pour water into it, it'll just sit on top, and the powder forms like a solid ball on the bottom. So they want you to tap the bottle or shake it a little bit until the powder flows freely. Then you take off the cap, and you're going to add approximately 2/3. So those are the special directions necessary. You're only going to put 2/3 of it in at first, because it's going to take up too much room if you try to put all the water in at once. So you put about 2/3 of the water in. Then you put the cap on and shake it up again. And then what do? Right after where it says total of 67 milliliters?
Then we add the remaining water or refrigerated.
Yes, so add the remaining water and shake well. And what I found a lot of times is in the pharmacy, the technicians or the pharmacist or whoever's doing this, which is going to be either a technician or a pharmacist, because clerks aren't allowed to do the reconstitution, they don't shake it long enough, you know, and you really need to shake this stuff up, you know, put your finger over the lid and shake it up for a good minute or so. In fact, some drugs will say shake for at least 2 minutes. So you're just like, you know, standing there shaking this bottle. And that's, you know, that's what you're doing there. And what is the volume of this dose in household measurements? So what volume of medication is necessary for a dose of 250 milligrams? So what's the concentration on this bottle once we mix it up?
125
125 milligrams
milligram
per
over 5 ml.
per 5 mLs. Good. And we want to give the patient how much?
250 milligram over
Yeah.
10 ml.
I'm going to end up with 1250 again, aren't I? Yep. 1,250 divided by 125 equals 10 milliliters, right? Okay, so then what is that volume in household measurements?
2 teaspoons.
Just like this one up here, right? We ended up with 10 mLs, which is 2 teaspoons. And that one was a half a teaspoon. Okay. One teaspoon, 5 mLs times 10 mLs over 1. 10 divided by 5 is 2 teaspoons. Good. Okay, and what instructions must be given to the patient when dispensing?
I think to shake it well and keep it refrigerated, right?
Yes, shake well, keep it refrigerated, discard after
10 days.
10 days, exactly. So what's the BUD on this one if we dispensed it today?
10, 11.
11. Yeah.
10, 11, 20, good. Okay, so that's mainly what you're doing in this, this whole chapter right here. And if you notice, most of these things, the concentration on all of these, except for the 375, the 375 is weird. Okay, this is 125 milligrams per 5 mLs right here, right? That's 160 milligrams. Even the 375 is divisible by 5. So all of these are easily divisible by 5, right? So another way you can do this is you can say, and go with a lighter color here. You can say 125 milligrams over 5 mLs is equal to 125 divided by 5, 25 milligrams per 1 ml, which means your concentration is 25 milligrams per milliliter. Okay, 25 milligrams per milliliter is the concentration. And it's most common that we see 125 milligrams per 5 mLs or 250 per 5 mLs. So if it's 250 milligrams per 5 mLs, what does that equal per 1 ml?
50.
250 divided by 5, yep, it's 50 milligrams per 1 ml. So this makes it very easy for pediatricians for older kids to figure doses and round them. So for instance, if they were doing 300 milligrams, okay, so you take your 250 milligrams per 5 mLs, right? 50, 100, 150, 200, 250, 300. So how many mLs do you need to give your patient now?
6.
6 mLs, exactly. So the drug companies make this concentration on purpose so that it's very easy to calculate these doses. Okay, does that make sense?
Yes.
Yes, now it does. Thank you.
Yeah. You know, I mean, they do some things that make sense sometimes. Yay, big company does something that makes sense. Yay. But sometimes that's hard to realize or to see sometimes because they don't always make sense in what they do. Okay, the other thing too, let's look at your post-test number 4 on page 181. So here's some help with the homework. They want to give the patient 32 milligrams of cephalexin. And it's available in 125 per 5. So let's estimate first. If it's 125 per 5, we know it's going to be 25 milligrams per 1, right?
Yes.
Okay, so we want 32 milligrams. 25, 50. Well, right away, we know our dose needs to be between 1 and 2 milliliters, right?
Yes.
Okay, so now if I do this math and I do 32 milligrams over 1 times 250 milligrams over 5 mLs, and I'm just very quickly doing this math, and I'm getting 32 times 250, 8,000 divided by 5, and I get 1,600 milliliters. 1,600 milliliters. Oh, I'm gonna need a bunch of these for one dose.
Excuse me, why you use 250? It's 125 in the question.
Oh, thank you. Okay, first of all, I was in such a big hurry that I didn't use the correct strength. Very good. Thank you.
You are welcome.
Okay, so 32 times 125. 4,000 divided by 5. Oh, I only need 800 milliliters. So I'm going to need half that many of these, right? Does that seem like a 1 dose for a child? That's like 2.5 of these.
Yeah.
No, of course not. That can't be correct, because when we estimated, we figured our answer should be between 1 and 2 mL. So what did I do wrong? I set this up as if it were a ratio and proportion problem, but then I did it like dimensional analysis.
Multiply 32 by 5.
Yeah, by
Yes.
5 divided by 125. You opposite.
Okay, so you want to be very, very careful. If you're using dimensional analysis, stick with dimensional analysis. If you're using ratio and proportion, and I'm fine with that because you're going to get the correct answer, just realize you're using ratio and proportion and don't multiply across. So here I have 5 times 32 is 160 divided by 125.
The answer is 1.28.
Is that between 1 and 2 milliliters?
Yes.
Yes.
We can round it, right?
Yeah, you could round it depending on how small your dose is. So you could do 1.3 milliliters.
1.3.
Now on a 3 milliliter syringe, which is this size, okay, so there's 1.2 milliliters, and there's 1.3 milliliters. So you could sort of gauge and go just above the 1.3 to make 1.28, and that's what we end up doing in the hospital. We want that black line to be visible above the 1.3 line, but just barely visible. Okay, so that's as close as we can get to being perfect there. And it's not really, see how it's just visible above the line? So it's actually closer to 1.3. Because if you go up any farther than that, then you're actually looking at 1.25 instead of 1.28. Okay. So we would choose the 3 milliliter syringe to measure this in, because you only have a choice of 0.5 mLs, 1 ml, those are too small, 3 ml or 5 ml, and your closest syringe is going to be 3 mLs. And this is probably about as close as you're going to be able to pull that syringe to, is to 1.3. And especially if you're giving it to a parent to do, you don't want to try and tell them right above that line. No, don't worry about that. Just, you know, it's going to be 1.3. Now let's look at what is the, you know, just carrying this a step further in our minds, because it's not in your book. What's the difference between 1.28 and 1.3 on this? So if we know it's 25 milligrams, 25 milligrams times 1.28 gives me 32 milligrams, right? So 25 times 1.3 is going to give me a little bit more. That's going to give me 32.5 milligrams. So it's going to be 0.5 milligrams over, right? So 0.5, let's look at our percent of what we call percent error. 0.5 divided by 32 times 100. And it's about 1.56%. Okay, so most of the time, if we're looking at something like this and we decide that this is as close as we can get to the prescribed dose and still be able to do it accurately, and our percent of error is less than, say, 5%, and this is not something that they go on and on about at the hospital, but this is what I've heard from other sources. If it's 5% or less, it's usually considered correct. So, and it depends on the drug though. Some drugs you can't go off by 5%. Okay, but here we're only off by 1.56%, so it would be perfectly acceptable to round, especially when you squirt that in a kid's mouth. A lot of times drug sticks to the inside of the oral syringe anyway. So, you know, it doesn't always get every single atom into their mouth. Because if it did, you wouldn't have to wash it afterwards, would you? But you know there's leftover drug in the syringe. That's why you have to wash them, you know, or not use them again. Okay, so your post-test doesn't look too difficult there. Let's look at chapter 10. Chapter 10 is the same thing, but they're parenteral doses. So we're talking about things that are injected. So there's something called an active-vial system, and this is a two-system vial divided by a seal holding a pre-measured amount of active ingredient in the lower section and a pre-measured diluent in the upper section. Dilution occurs when you press down and mix the two together.
Excuse me, Dr. Lopez.
Yes.
Can I leave the meeting? I need to take my mom to a doctor appointment.
Sure.
Thank you so much.
Thank you for participating.
Thank you. Have a good one.
You too.
Bye. Bye.
Bye.
Bye, guys. Have a great one.
Okay, so I was actually able to Google this active vial system so you can see it.
Oh, sorry. I didn't know I had my computer not on mute.
Okay. Let me see if I can find it on here. Because the way they describe it, it doesn't always make sense. So this comes as solucortef for one thing. So let me see if I can figure out how to stop the share for just a minute and then share from this computer. I have to make myself the host again. Oh, it's so much fun to watch me try to handle technology. Name, pin, spotlight. No, how do I share on here? It only wants me to share on this other computer. Okay, finally, oh my goodness. Okay, so this is that actovial, okay? So your solucortef, the powder's down in here, and the liquid is up in here. So when you flip off that little plastic thing here, you can push down on it, and there's a rubber stopper in here that pushes the liquid down, and that liquid forces this rubber stopper down into the bottom, and the liquid comes down and it mixes. Okay, so that's one actovial system. And then there's another one called advantage vial. So this is for a bag. Okay, and let's see if I can find the picture of them stuck together.
And after combining the powder and the liquid, it's only used once, right?
Yes, because that's only 2 milliliters in that whole vial, so you're going to get all your doses out of it. Yeah. Okay. So it's something like this, where you attach one end of it to the bag of diluent, and the other end is going to be your powder. Okay. So, and it's not Advate, it's Advantage. Advantage bag IV. Okay, this should do it. No, that's still not showing me what I wanted to see. So, all right, let me go back to here. And go back to sharing this screen. Okay, so now we're back to where we were. Whew. I swear, in about 10 years, I'll get so good at this, and all of you guys will be ready to retire from your careers. Okay, that was a joke. It's okay. Okay, then we have an ampule, which is a sealed glass container that holds a single dose of medication, usually for injection. With a glass container, it's almost like a bowling pin, and you have to literally break the glass. So then you take a needle with a syringe with a filter needle attached, and you draw up the medication out of it, and then you switch the needle, because the filter needle filters out any microscopic glass particles that might be on there. And then you use the other needle to inject, because you don't want to push, like if you have a needle that has a filter on it attached to a syringe. Okay, this filter is going to draw up glass on this side, right? It's going to filter out impurities on this side. So you don't want to push liquid back out through the filter, because you'll push the glass out. So at that point, you have to change the needle. So you could put another filter needle on it, or you could put a regular needle on it because it's already been filtered once. So that's, you know, how you do that one. And you don't use glass ampules without using a filter needle. Okay, the infusion is a slow administration of fluids other than blood into a vein. Intradermal is into or within the dermis of the skin, like a tuberculosis test. Intramuscular, into or within the muscle. Intravenous, into or within a vein. There's another one called IT, which is intrathecal, and that goes into the spinal column. Okay. And then a large volume parenteral are IV bags that are larger than 250 milliliters up to 3 liters. A small volume parenteral is under 250 milliliters. Parenteral is administration outside the GI tract, mostly considered to be by injection or infusion. A piggyback is a small volume IV, 50 to 250, with added medication administered through an established IV line that is kept patent open by a continuous IV solution or by flushing. Subcutaneous is beneath the skin, medications injected into the subcutaneous tissue. They call that SQ or subcute. Therapeutic range is a dosage or blood concentration range that normally produces desired results. Too much may be toxic and too little might not be useful at all. It might not achieve the desired effect and or not be therapeutic. A vial is a glass or plastic container. This is a vial. With a metal enclosed rubber seal. So it's got a rubber seal in there and then plastic or metal around it. So if you peel off this metal seal in the middle, you can see the rubber underneath there. So you'd have to take this off and then inject through there. Some of them have a plastic cap on top of the metal seal. So then you would pop off the plastic cap and you would see the metal seal with the rubber stopper in the middle. So it looks exactly the same. May contain single or multiple doses, and it'll tell you if you can use it for multiple doses or not. Okay. If you look on page 188, you can see the glass ampules on the left and the vials on the right. There are a few drugs that use grains per milliliter, but most of them are going to be milligrams, grams, or micrograms per milliliter. Some grains are not common today, but once in a while you'll find that. You'll also find drugs measured in IU, which is international units. Can't spell today. Or MEQs. MEQ is milli-equivalents, or lowercase m, capital M, and that's not a microgram symbol, it's just a uppercase M, which is millimoles. So a mole refers to Avogadro's number, which is the equivalent of however many molecules are in a mole of carbon. So it compares it to carbon. Milli-equivalents has to do with the atomic weight divided by the valence. And it's based on the mechanism, it's based on the action potential of the drug. So a lot of times these are used for electrolytes. So for instance, potassium phosphate, the potassium is measured in milli-equivalents and the phosphate is measured in millimoles. So you can see how many milli-equivalents of potassium the patient's getting and how many millimoles of phosphate they're getting. So in something like total parenteral nutrition, you have to balance all of those things so that you have the correct amount of all of them. Okay, so if you're looking for phosphorus or phosphates, you're going to be using millimoles. If you're looking at potassium, you'll be using milliequivalents. If you're looking at a vitamin product, you'll be looking at international units. But most of what we do is going to be milligrams per milliliter. Probably 90% of everything you do, at least, is going to be milligram per milliliter. Okay, so page 190 and 191 shows you a bunch of syringes calibrated and measured to different volumes. And it asked you to see how many milliliters are in each volume. And then that's going to be what you're doing on your math for this chapter 2, is you're going to be drawing the syringes and indicating how many milliliters. So if you go over to page 194, let's look at example 10.2. This is aminophylline. Aminophylline is similar to theophylline, and it can be used for severe asthma attacks, and they use it for a few other things as well. And it's a 20 milliliter vial, which is 4 teaspoons. This is 10 mLs, so it holds about twice as much as this bottle of sterile water, the vial. And it says the whole thing is 500 milligrams, which is 25 milligrams per milliliter. And we want to give the patient 125 milligrams. Okay, so you're going to give this 125 milligrams intravenously every 6 hours. When interpreting this label, the strength of the medication can be read as 500 milligrams per 20 mLs or 25 milligrams per milliliter, because these are equivalent fractions. The entire 20 milliliter ampule contains 500 milligrams, but only part of this is needed for each dose. Either strength designation may be used to calculate the dose, but the smaller numbers keep the calculations more simple, okay? After reviewing the following examples, etc., and it'll give you the same answer is what it's saying. Look at the tech alert on page 195. If the answer to a dose calculation does not agree with the anticipated answer based on the amount of medication prescribed, the dose of medication on hand, or the intended route of administration, always recalculate, ask for assistance if necessary. And then as you come down, another tech alert, usually if an injectable dose is less than 1 ml, it should be rounded to the nearest hundredth. So if you have questions regarding acceptable rounding techniques, ask your pharmacist for assistance, or your charge nurse, because they've been around and done it all. Okay. The intended route of administration, you can't, inject 30 milliliters into a muscle. I mean, you could, but it's going to really mess things up in there. So it's bad. It would be extremely painful and cause all kinds of problems. So depending on where you're going to inject something, you're going to have limits on the volume. So in this case, we're looking at intravenous, and intravenous, you can go up to much higher amounts because it's mixing into the bloodstream. And if you infuse it over a slow period of time, you can eventually infuse several liters of fluid over several hours. But we're looking at this every 6 hours. So we're going to talk about this a little bit more later, because we're going to talk about IV piggybacks and large volume parenterals, and we'll be talking about milliliters per hour, milligrams per minute, drops per minute, milliliters per minute, and we'll be getting into all of that pretty soon. Okay, so if I were going to give 125 milligrams here, how many milliliters would I need?
Five?
Yep. So it's going to be 125 divided by 5, which gives me, divided by 25, which gives me 5 milliliters. okay? So practice problems B tells you to use the method of calculation with which you're most comfortable, ratio and proportion or dimensional analysis. Remember that DA is best for multi-step conversions to keep track of units. Round to the nearest tenth unless the dose is less than 1 ml, and then round to the nearest hundredth, okay? So if it's 1 ml or more, round to 1 decimal place. If it's less than 1 ml, go to 2 decimal places. And that's a pretty good general rule, and that's what I want to see on the post-test, okay? On the bottom of page 196, it does the same thing that we did in the previous chapter with the, what was that again? Okay, I'm not finding it, but remember how I gave you 3 different strengths up here? And then you had to calculate based on which one you were using. It was this one. You had 125 milligrams per 5 mLs, right here, or 250 milligrams per 5 mLs, or 375 milligrams per 5 mLs. Okay, well, your chapter 10 also does that. On page 196, okay, so it's giving you 3 different strengths to calculate there as well. Okay. Let's go with green for fun. So page 196, number 5. And it says meperidine 75 milligrams intramuscular every 4 to 6 hours as needed for pain. Meperidine is Demerol, right? Okay. So it's a pretty strong pain medication. They use it a lot in labor, or they used to when I had my kids, you know, a very, very, very long time ago. You don't see it so much anymore. I think most hospitals are using morphine and Dilaudid. But anyway, so it comes 25 milligrams per ml or 50 milligrams per ml or 100 milligrams per ml. And it also comes like the 25 milligrams per ml is a 1 ml vial. And the 50 milligrams per ml is also a 1 ml vial. And the 100 milligrams per ml is a 1 ml vial. So they're all 1 ml vials. Okay, so what strength would you use for this order? Hint, this is an intramuscular injection. So remember, if you inject a large volume into a muscle, it really hurts. So which strength would you want to use for 75 milligrams?
Probably the 25 mg.
The 25? Okay, so 75 milligrams. So that would give me 3 milliliters, which is more than half a teaspoon, and you're going to have to inject it into a muscle. So is that going to be comfortable?
No.
No.
Okay, what if we did 50 milligrams?
Yeah, that comes out to, I think, 1.5 ml.
So that would give you, so this one is going to be 3 mLs. This one would be 1.5 mLs. And the 100 milligrams per ml works out to what?
I think 0.75.
Okay, so 0.75 is not going to hurt that much, is it? And it's also easy to draw up. You can go to 2 decimal places on a 1 ml syringe. So this is an oral syringe, but you get the idea. So 0.75 is between 0.7 and 0.8, or right about there. So this amount would be fairly easy to inject. It still might hurt a little bit, but then because it's not dilaudid, it's Demerol, you won't feel the pain in a minute, right? Usually a few seconds. Okay, so why did you choose this vial? Because we want it to be less painful. Smaller volumes are less painful. What volume is needed per dose? We already did that, 0.75. Indicate the amount of medication on the appropriate syringe. And depending on which, you could use either one of those syringes. You have a 1 ml and a 3 ml syringe, so you could pull up 0.75 on each one of those. So that's what you're doing with this chapter. You're calculating doses, and then you're marking it on the syringe. I love that they do ask you some other questions, like, hint, this is an intramuscular injection, which strength should you use for this order? So I do like the way that this book is written.
Can we go over number 11 on page 199?
Yes. Prescribed lincomycin, 0.45 grams, intramuscular stat. Stat means what?
Immediately.
Immediately.
Fast.
Yeah, super fast, immediately. If I had to go down to the IV room and get it, I would have 15 minutes to get it back up to the patient or to the nurse. So yeah, stat is like within 15 minutes, which sounds like a long time, but you know, depending on where you have to go to get it. I would have to go down from the 5th floor to the 2nd floor, and I could take the stairs, but I can't go back up 3 flights of stairs. It would kill me. I would need my lincomycin. No, not really. I'd probably need epinephrine. And so you're interpreting the order, and it says to inject lincomycin 0.45 grams intramuscular stat. Your stock available is 300 milligrams per milliliter. And you have a 2 ml vial. Okay, when it tells you you have a 2 ml vial or you have a 1 ml vial, set that information aside. You only need that information if it asks you how many vials you need, okay? I have a lot of people that try to take this 2 mLs and put it in their calculations to figure out how many milliliters to give for the dose. So don't worry about that, okay? So I want to know how many milliliters. 1 ml contains 300 milligrams. So I'm going to set this up with a conversion factor in the middle, which is why I love dimensional analysis. There are 1,000 milligrams in 1 gram, right? And we want to give the patient 0.45 grams. So 1 times 1,000 times 0.45. Gives me what?
$450.
Yes, 450. And what do I have on the bottom?
300?
300.
Okay, 450 divided by 300 gives me what?
1.5.
1.5 what?
Milliliters.
Milliliters, good. Because the grams canceled and the milligrams canceled, didn't they? The only unit I have left is milliliters. Okay, good. So what volume is needed for this dose? 1.5 mLs. Okay, did you ask about it because of the gram thing?
Yeah, I wasn't too sure, so I want to make sure it was what I was doing right.
Right, exactly. Because the small g, I don't know, this large G, small g is the same thing. Okay, page 201, where it says tech notes, this could also be called nurse notes. The directions on the label should be read carefully first and followed exactly to prevent errors in the reconstitution process. So again, it's really extremely important to follow this information because a lot of drugs, when you reconstitute it, it doesn't shrink, okay? It expands because you're putting liquid into a powder and you're going to have some powder volume. Something like vancomycin, I found out that vancomycin has such small powder volume that we don't even count it. So if we need 50 milliliters of vancomycin, we're going to take the powder and we're going to put in 50 milliliters of water, which was kind of like, that's crazy in my head. But that's the way it works out because it's so light that it doesn't add any volume to it. So it's really strange. It's a very super powerful drug. So this talks about, on page 201, talks about reconstitution. Parenteral medications that are unstable in liquid form for extended periods of time are manufactured in a powder form for reconstitution before use. In other words, you can keep this bottle of, or this vial of powder on the shelf for months or even a year or two. And if you mix it with water, it's usually only good for 24 to 36 hours. In fact, there's a drug called olanzapine, and it's only good for 1 hour after you reconstitute it. So when we get a call for that drug, we have to mix it and run it. It's almost always stat because they need it immediately. And we'll even call and say, when is this due? So that we know, oh, it's due at 3 o'clock. Okay, thank you. And then we'll mix it like at 2:45 and run it right over. Okay. The manufacturer's label states the total quantity of the drug in the container, usually in grams, the volume and type of diluent to use to attain the desired strength, the final strength of the medication after reconstitution, and the stability and storage requirements before and after reconstitution. To reconstitute a medication, follow it exactly. And then the medication must be completely dissolved. So once you add water to the powder, you need to look at it and make sure that it's completely dissolved before you pull it up in the syringe to mix into an IV bag or to take over to the, to give to the patient. So we want to make sure they're completely dissolved. Some injectable powders are manufactured with diluent and powder in 2 separate chambers, such as hydrocortisone. This particular system is called the Actovial system. Some of them will actually have a bag that has a divider that is stuck together, and you have to squeeze the bag, which pushes air up into the area where the water is, or the diluent, and then it will fall down into the powder. So that actually comes in a bag form also. Some drugs may require bacteriostatic water for intramuscular injections, or even require specific diluents, such as those with a small amount of anesthetic to prevent discomfort. So when we get a powdered drug, we always need to find out, what can I mix it with? Okay, what kind of diluent am I using? Most of the time, our diluents are going to be either sterile water or 0.9% sodium chloride, which is called normal saline. Okay, so they're going to be either normal saline or water. There's a few that you mix with D5W, which is 5% dextrose. Those drugs can usually be stuck together, and the D5W is injected into the powder vial, and then we pull it back out into the bag. Okay. If the solution for reconstitution is not indicated, consult a drug reference. One of the ones I like to use is the Injectable Drug Handbook. And we have a paperback copy of it in the pharmacy. And a lot of times I'll just go grab it, and then I'll look up the drug, and it'll tell me what I can use to reconstitute it. Once the appropriate diluent has been identified, the amount of diluent for the desired dose must be verified. Vials of some multi-dose parenteral drugs may be diluted with different volumes to attain different concentrations for different routes of administration, exactly as shown as the Pfizer pen label on page figure 10.8. Okay, so Pfizer pen is penicillin G potassium. No, yeah. Okay, so there's another tech alert at the bottom of page 201. Never assume the directions are the same as previously found on the same medication. Read the label directions every time the medication is reconstituted. Because you can't, you know, maybe your purchaser got a better deal on a different drug company's product, and maybe that powder volume is different. So you always want to look at that label and verify, you know, like with Rocephin, it's always 8.2 milliliters of water and you end up with 10 mLs. But again, look at the label every time. So look at this Pfizer pen label on page 202. And it gives you choices. So if you look down on the right-hand side at the bottom of the label, it says, it tells you what the recommended dosage is. Sterile solution may be kept in the refrigerator for 1 week without significant loss of potency. And then it says the milliliters of diluent added, and then what the concentration is in units per milliliter. So if you add 18.2 milliliters of your diluent, which in this case is going to be sterile water for injection, or SWI, you're going to end up with 250,000 units per milliliter. Now, if you add less water, it's going to be stronger, right? Because you won't have diluted it as much. So if you add 8.2 milliliters, you're going to end up with 500,000 units per milliliter. And if you add 3.2 milliliters, you're going to end up with 1 million units per milliliter. Okay, so it lets you choose how you want to do that. Now, if I'm going to put this whole vial, 5 million units, into a 100 milliliter bag of D5W, which we do, this is called a loading dose, and this is usually given to most moms when they first go into labor. And they do that just to prevent infection. And so if I'm going to do that, I usually go with the 8.2 because it's easy to draw up. It mixes very well, very quickly, and I can shoot it directly in the bag. If I want half of that amount, then because that's the loading dose, that's the whole entire vial. But the subsequent doses every 6 hours after that are going to be 250,000 units. So no, this whole thing is 5 million units. So I'm going to do the whole thing and put it in there. But every dose after that is going to be half of that. So it's going to be, instead of 5 million, it's going to be 2,500,000 units, or they call it 2.5 MUs. So when we say that it's 5 million units, then we're not going to actually write out 5 million units. We might also call it 5 MU, which is 5 million units. Okay, does that make sense?
Yeah.
Okay. So if I'm going to put the entire vial of anything into a bag, what's most important is the total volume after I add it to the bag. So let's say that I have a 50 milliliter bag and I have a drug that needs to be reconstituted, and it's a lyophilized cake dried of drug. So let's say that this is normal saline, and I can reconstitute this with normal saline. I can take out 5 or 10 milliliters as long as it will fit in here, reconstitute it as long as I shoot the whole thing back if I want the entire drug, right? Entire vial. So it could be any drug, it could be any amount of drug. It doesn't matter. If I'm going to put the entire thing into the bag, I can reconstitute it with whatever amount will dissolve it as long as I take it out of this bag and put it back in that bag, right? Does that make sense?
Yes.
Okay. Because let's say it's 100 milligrams of doxycycline. It doesn't matter what I reconstitute it with, as long as it's enough to reconstitute it well and get it all completely mixed up, and then I put the whole thing back in the bag. Now that might increase my volume a little bit, but not enough to really matter. However, if I'm going to use only part of it, then I need to make sure that I use the correct amount of diluent, because I'm going to have to calculate how much is going to give me a portion of that vial, right? Okay, so that was something that after teaching math for years and years, and then going into the hospital, and I was told, and I was like, how much do I use? Well, it doesn't matter, you're putting the whole thing in the bag. Wait, but how much do I use? I mean, I was literally like stopped. Why doesn't it matter? Okay, and then, you know, I had a technician who was at least 20 years younger than me and say, because you're going to put the whole thing back in. Oh, okay, all right, let's, you know, and then they showed me how they did it, and I was like, okay, now it makes sense. But, you know, I was so stuck on this, you have to use the correct amount of volume of diluent, or you're not going to get the right concentration. You're going to end up diluting it in the entire bag anyway. So it's kind of funny how, you know, our brains, no matter how old we are, we can get kind of stuck on something, and then we have to rethink it sometimes. So you're going to calculate, and it's okay to use your 8.2 milliliters and get the correct amount, even though you're going to put the whole thing in the bag, you know? That's all right, because it gets you used to doing that when it's really important. Okay, so look at that tech note under the Pfizer pen label. The less diluent added to a specific container of medication, the more concentrated the medication. When reconstituting medications with multiple strengths possible, choose the strength closest to the physician's order that will provide a dose appropriate for the intended route of administration and with the least chance for error. So we've kind of gotten in the habit, all of us, to use the 8.2 milliliters, and that will give us 500,000 units per milliliter with the penicillin, since we use it so often. Okay, decide on the amount of diluent to add and prepare this for use in figure 10.9, which is over on page 203. Okay. The label reads to add 2.7 milliliters of sterile water for injection. After injecting the diluent, the mixing process is accomplished by inverting the container slowly, unless otherwise indicated by the manufacturer. Shaking the container may decrease the effectiveness of some medication and may cause the liquid to foam. Foaming will make it difficult to withdraw the correct amount of medication. And then you also need to note how long is it good for, what are the storage directions before reconstitution and after reconstitution. And so now they're looking at page 203, this oxacillin sodium for injection, buffered for intramuscular or IV use. It's 500 milligrams in the vial, and those are very tiny, tiny printing on those directions. So I get this a lot. These little vials are so tiny. So a lot of times I make sure that I am focused with my camera. I take a picture of it, and then I can enlarge the picture. And the first time I did this for a pharmacist who's about my age, she said, "Oh, I never thought of that." It was so cute. Like, you've been a pharmacist for this long and you never thought about that. There's no patient information on here. So I am not violating HIPAA laws by taking a picture of the label. So it says, add 2.7 milliliters of sterile water for injection. Each 1.5 milliliter contains 250 milligrams of oxacillin. And then it says discard solution after 3 days at room temperature or 7 days under refrigeration. Okay, so that's what that tiny little label says, which is really hard to read. That is not a great picture. See if that one looks better. Oh yeah, that one looks much better. It's still a little bit blurry, but I think it's because it's printed so tiny. Okay, so practice problem C on page 205. Do you see the Pfizer pen label? Here's the answer to the first part of the math. We just did that question. And then it says what routes of administration can be used after dilution, how long can the medication be stored in the refrigerator. So all of this is what you're doing for this chapter, okay? Your post-test contains only 10 questions, okay? But it goes to page 2, from 207 to 210. And there's multiple questions on each problem. So you might have to answer questions about storage, what volume, draw it on the syringe, and then interpret the order. It might even ask you about storage or what route you would use to infuse the medication. Do you guys have any questions about this?
No, I think I'm good.
Anybody else?
No, thank you.
Okay. All right, so that's chapter 9 and 10, and you're going to have one quiz for chapter 9 and 10. It might be a few extra questions, but probably not, because, you know, the math is the same, right? Wouldn't you agree?
Yeah.
The powder volume, the milligrams per milliliter, how many milliliters you add, questions about storage, things like that. So, you know, I think it's not super difficult. And especially if you practice it. And if you have problems with the post-test, go back and do some of those practice problems. Okay. I thought my computer was plugged in. Why is it telling me to plug in my computer? Oh, okay, I see what happened. My husband plugged something else in for me. And so now my computer is saying it's running low. So, all right, I'm gonna go plug in my computer and grade all the homework that came in over the last few days that I haven't had a chance to look at yet. So.
Professor,
Yes.
Professor, I do have a question about the prescription transcription exercise.
Yes.
On number 3 says Norvatch 10 milligrams, 30 tabs, and the SIG says 1 tab. Is that OD, AD? I can't figure out what that letter is before the letter D. Okay.
Was that the exercise that I gave you the prescription of? Was it the prednisone one?
No. No,
Okay.
This one's different.
Is it in the book?
It is not in the book. It's on it's under files or assignments. It says prescription transcription exercise.
Oh, okay.
It has the Xanax, the Colace, and Norvatch.
Yes, okay. I know which one you're talking about. Where did I put it? Okay. Ian, drop me an email on that and I will address it either in an announcement or does anyone else want to see that too?
You gave directions as to what you wanted.
Okay.
So I went ahead and did it already.
Okay,
Yeah.
okay.
I'm
So
good.
I'll email you back with that, Ian, because I'm don't know if I'm going to be able to pull it up here. It's not even letting me minimize this. So,
Yeah, it's just that one letter. It looks like an O, OD, but at the same time, it can be construed as an A. So I
is
just
it an
wanted,
eye drop? I didn't think that one had eye drops in it.
no, it's either an eye or either eye drop or an eardrop. So
What
that's
does
why I
it
was trying.
say?
It says Norvatch 10 milligrams, 30 tabs. The SIG says 1 tablet,
Uh-huh.
OD, or it could be an AD.
Okay, so OD would be right eye and AD would be right ear. So you're not going to put a tablet in those. So it's not going to be that one. It could be PO, or it could
No.
be, like I said, I don't have it in front of me and I know what you're talking about and I know exactly where I got it. So I can go look at it, but I left that book in the other room. So yeah, drop me an email and I'll answer it for you, okay?
Okay, thank you.
All right. Anybody else have any questions?
No, thank you, Professor.
No, thank you.
All right, thank you so much for attending class. I appreciate it. It's really hard to lecture and record a lecture with no feedback. I'm constantly going, does that make sense? Oh wait, there's no one out there. So yeah, I appreciate you guys showing up. All right, have a good week and email me if you have any questions and I'll talk to you later.
Sounds good. You have a great one.
Okay, thank you.
too.
Have a good week.
Thank you. Bye.
Bye.